Hey, what's up, Franklin West? I have part two of the how to solve for the surface area of rectangular prisms video. There'll be three of them. The first one, if you watched it or not, was about how to just approach the ask of how to calculate the area of all six sides and add them up together for a total. And that one was done without units. This next one is going to up the ante a little bit, so to speak, and we are going to do the same work but with decimals. And we are also going to layer in, just double checking, units. And so with the decimals, we'll bring in a chance to talk about how to round so that we don't risk over rounding throughout our work and distorting our final answer, and also how to deal with units when you are going from one dimension to two dimensions. So for example, when you're calculating area, it's going to square your unit just like it might, well, if you're doing 4 by 4, square your area, square your number. So what happens when you have inches times inches or feet times feet? And how do you convert if you are working in inches, for example, and solve the area and you get inches squared? But then the answer wants you to report in feet squared. How do you convert from inches squared to feet squared? And so there's an added layer of challenge in that way also. So I would say this video content related to surface area calculations for rectangular prisms includes Proficient and into extension material a bit. So it's a great way to stretch your learning. So if you're feeling like this is your avenue, jump right on in. If you feel like you got it, but you're a little nervous, there's no harm in watching a little bit. Stop the video at any time if you are totally hating it. But always feel free to reach out if you have any questions. Use the school email or comment below if you have permissions. Enjoy the video. All right, here we are. We have a second rectangular prism to work with today. Again, the focus is going to be on decimals. And so our first, I'll just move it over so we have a bit more room. I'm also not going to take the time as carefully as I did in video one of these series of really trying to identify each face so thoroughly as I did before. We're certainly going to talk about it, but I'm not going to build each separate face and build their dimensions there. So we'll just follow my cursor as I outline sides and talk about edge lengths. So we're going to say that this is a, oh, I don't like that. I'm going to get into the black color. So 6.1. So we're going to work with decimals. So this is a 6.1 by a 2.8, and this dimension here is by a 9.5. Okay, so we are working with finding the total surface area of all six faces summed up together, so adding them all together. So when we jump in here, and actually I should say it again at the start of this section of the video, we're not going to do any rounding until the very last step. And this is a strategy you should use in all of your coursework in any subject. So whether it's any sciences or math, you don't want to do any rounding until the very last step. So, and if you've got a calculator in front of you, let your calculator keep all those extra digits past the decimal point in there for you. Just by starting the next operation, most calculators are just going to load your prior answer in its screen into the next round of operations that you're going to do. And that way you don't have to write down all these long digits and you don't have to retype them. Your calculator can do that part for you. So with that in mind, we won't do any rounding until the very end, and then I'll guide you on how we should round based on the dimensions that were given to us at the start. Okay, so we've got this face here matches this face here. So we've got a 6.1 edge by a 2.18 edge. And actually, just because that decimal doesn't always work well, this is going to be two faces multiplied to 6.1 times 2.8. Okay, and then we have this face here, this lateral side, is also equivalent to the side over here. And so that has a 9.5 dimension by a 6.1 edge here. And again, there's 2 copies of that as well. So, and I'm going to set up to already jump in to show my adding. I've got 2 faces that are a 6.1 times 9.5. And then I have the top and the bottom faces that are also identical here. This is a 2.8 edge that is being multiplied by a 9.5 edge, and again 2 copies of that. So that was a 2.8 times 9.5. Excellent. It's still common when we are working with dimensions like this, calculating areas, or if you're calculating volumes, that the X would be used. In high school math level, algebra level, the X no longer is a multiplication symbol, or we don't use it in that way anymore because X might mean a variable. And so in my next video, I'll make sure to not use this times. So this will be the last time that you see in this series X representing multiplication. I'll show you some other symbols that we tend to use. And parentheses, as you know, is one multiplication symbol that helps us navigate the problems. Okay, so we kind of flew through that pretty quickly. It should all be organized. Notice we have 2, 4, 6 faces here. And so those are all accounted for. So we really need to go through this process of 6.1 times 2.8. Now I know we have calculators in front of us, but we want to make sure our brains don't get too tired. And so I challenge you right now to follow along with me. We're going to do 6.1 times 2.8 because we might just want to double check we still remember how to multiply with with decimals. Okay. So at this point, you just put them in together. They don't have to line up decimals. They just happen to because they both are just to the 10th spot. And so it's multiplication. If we're adding and subtracting, we certainly would want to line up those decimal points, but we don't have to here. So we're going to temporarily ignore this. We could think of this as 61 times 28 and then figure out the decimal placement thereafter. So we have 8 times 1 is 8. 8 times 6 is 48. And then we jump over to the tens. So whatever I write down as an answer here, I'm going to put here instead because I won't have a ones position to account for here. Because that's really a whole, or in this case without the decimals, like a 20 spot. So 2 times 1 is 2, and 2 times 6 is 12. And so we go through and add it all together. 8 plus nothing is 8. 8 plus 2 is 0. We're going to carry a 1 over. So 1 plus 4 is 5, plus 2 is 7. And then nothing to add to this one spot. So we have 1708. But now we've got to go back and see how many digits to the right of the decimal point were there. Well, there was 1, 2. So moving here, we have the last 2. Should be to the right of the decimal point. So 17.08. That's what this represents here. 17.08. Now, just for the sake of the video, because I don't want them to get too long, they're already longer than what I'm hoping they'll become. So I am going to do a calculator for the next ones. But what you could do is pause the video right now and try your hand at doing it the long way. Just double check that you still got it, because that's a good way to use our brains, right? You use it so you don't lose it. So 6.1 times 9.5, we're going to double that. We should get 115.9. So 115.9. I'm just going to double check that I typed everything correctly into the calculator. I did. Then I have 2.8 times 9.5 gets me a 26.6, which then I have to double. So notice and that gets me 53.2. So notice how I spoke the second one, how I put it in the calculator versus how I spent the third. And actually, do you see what I just caught? This is so easy to do. What I did was 6.1 times 2.8 multiplied together. But what did I not do yet? I didn't double it. So important. Okay, so This is so easy to do in our work. So if this happens to you, don't ever use it as a piece of evidence that says you can't do math. Here I am as your support teacher, and I made that mistake. It's so easy to do. So I'm going to, and really it wasn't a mistake, it was just an oversight. Okay, so we're doing well. So 34.16 is what I get here. So again, 3 numbers, even though they're representing a total of 6 faces. This represents front and back. Each one individually was 17.08. I've got 2 of them. That gives us a total area of 34.16, and so on down the line. So what I was trying to say before I caught this little problem here was I can multiply these in any order. I can do 6.1 times 9.5 as the way to calculate the area, the actual area, and then double it. Or I could do 2 times one of those dimensions and then times the next dimension. No matter the order, you're going to be the same result because it's multiplication. So no matter the way you order, 5 times 3 times 2 is the same thing as 2 times 3 times 5. You can have that flexibility in your multiplication. So we're looking for a total. So we're actually going to add all these. These are areas of each paired face. And so now we need to add all those together. So because I modeled multiplying fractions, let's model just to make sure we remember it. Because you know what? Even when you're in high school, sometimes you still got to be able to demonstrate the stuff you learned years ago. So we should take a moment to do that. So this time I do have to write very carefully. I need to make sure I line up every value position with the match. And I have to line up the decimals. Okay, there's no option there because this right here is the hundredths position. There's nothing listed in these hundredths positions. I get to assume they're all 0. Right? I would hate to add the hundredths to the tenths. That would totally be a distortion of value. So then I have 1 plus 9 is 10 plus 2 is 12. I'm going to bring down the 2 in the decimal point and carry the 1. I've got a 5, and a 5 is 10, and 3 is 13. Carry another 1. And then I have 3, 4, 5, and then another 5 is 10. So carry the 1 and 2. Now, just because I didn't prep this part all on my own before I started this video, I just am going to throw it into my calculator just to make sure I didn't do anything silly, because what I'm noticing, as sometimes it happens at the board, when I'm writing something different than what I'm saying, which happens sometimes in these videos, things can get a little off kilter. So, but this is correct, 203.26. This is your final area, okay? This is a collection of all the surface areas of this rectangular prism. And you could stop there. However, we just have to make sure that we didn't introduce any information here that we didn't actually measure. So for example, and this comes into the rounding. So for example, that's 6.1. It's not 6.1 and then another number. We have no idea what's in this 100th spot. Same thing with these other 2 terms also. And so it's in the best interest, this happens in math and science, that we probably should round to the nearest tenth, because we are not reporting anything higher than that, right? We don't know what's happening outside of the 0.5, the 0.8, and the 0.1 as it gets smaller and smaller there. So I have 203.26, and based on our rounding rules, we should round it to 203.3. And that should be our final answer. Excellent. Okay, so we're going to slide over. I have another one prepped. I'm just going to bring it on over here. And we're going to, in the same video, add this other challenge. So we just practiced with decimals and reminded ourselves how to multiply and add decimals. But now we've got to really talk about units. That would be the responsible thing to do if we're talking about lengths, widths, and surface areas. So I'm just going to put in some dimensions. So we're going to say that this is 5 inches. And this dimension is 2 inches. So, and actually centimeters, meters, those kilometers, miles, feet, we could have used all kinds of distant units to help us out. I am being, I guess, totally American and working on this British system, but probably I should have done centimeters or meters to help us out globally. Maybe I'll save that for another video. Okay, so we've got a 5 by 2 by 11, all in inches. That's actually a good scan that you should do when you take a look at these problems, when you encounter them in other places. Double check they're all in the same unit. You really couldn't proceed if some of them were in, say, centimeters and one in inches and one in feet. You'd have to pick which unit you want them to all be in and make them convert the ones that are not in the unit you desire, convert them according to conversion factors you can find online. Okay, so but I'm starting us off where they all have the same unit. And we're going to continue the work as we have been, right? So we are going to find the area of this face and this face. They are the same. They have the dimensions of 5 inches by 2 inches. And so we've got 2 of those faces, and this is 5. I'm going to put a space in there. Oh, I'll do it this way, 5 inches by 2 inches. And I'm going to try to show multiplication there. Excellent. Okay, so continuing in there, we're going to add to that another face. So this right here, this face is an 11 inches in dimension there, and this edge is the 5-inch edge. So again, with 2 faces, so 5 inches times 11 inches. And we're going to add to that the top and bottom face, which again has a length of 11 inches, but this width edge of 2 inches. And there's 2 faces like that, so 2 inches by 11 inches. So see how we have 3 unique areas. Okay, so let's go through and do this. 5 times 2 is 10. Double that, we should get 20. But we got to take care of our units in the same way. So this is inches times inches. Seems weird that you could do that with your units, but that's actually exactly what we're doing. So we have to treat our units like numbers. And so if it's inches times inches, well, that's inches squared. So if you see this, so if you have like inches squared, that is an expansion would look like inches times inches. And that's exactly what we have here. So just a shorthand. So just like when you saw this as 4 squared, 4 times 4 was what that was meaning. That's what it means in the units too. It just looks different because we're using units instead of numbers, but the rules are the same. And so now we have 5 times 11 is 55. We double 55, we should get 110. And the units we want to track, so those are inches squared. Remember, whenever we're dealing with area is always a squaring. I should have typed this. So we're always squaring. Okay, so your units will always go to the second dimension. If we were calculating volume, that's length times width times height. That's 3 units or 3 dimensions. And so area, volume will be cubing, but area is squaring. Okay, so continuing, 2 times 11 is 22. Double that, we should get 44 inches squared. Excellent. Okay, so we're doing what we did last time, where we are totaling. These are all individual areas of 2 faces each for a total of 6 faces. We're going to add that all together. We have 20 plus 110 is 130. 130 plus 44 should get us 174. Now we can only add them because they are all the same unit. That brings us back to this problem here. If any of these were not the same unit, we'd have to create that uniformity by converting. Otherwise, this is almost similar to like terms. If I can't add inches squared to centimeters squared, that'll distort the value. It won't make any sense. And so we can only add these because they are all inches squared. So it's 174 inches squared. And that is our final answer here. But let's say your teacher adds another layer of challenge and they say, report your final surface area in feet squared or in square feet. Either way, you could say that. How in the world do you approach that? Well, you need your conversion factor. We know that there are 12 inches in every 1 feet or 1 foot. Okay. So that's an important ratio. When we can actually write that as 1 foot over 12 inches, either way, it doesn't matter. It looks funny. This looks like it's 12 over 1, and I'm saying now it could be 1 foot over 12 inches, but that's 1 over 12. They don't look like they're the same in value, but actually they are because of the difference in units. Every 1 foot has 12 inches within it, and so this is a value of 1. It's kind of like a dozen eggs. There are 12 eggs in every 1 dozen, and no matter how you write that, 1 dozen over 12 eggs or 12 eggs over 1 dozen, that's actually equivalent. So there's a beauty in this. We can take this conversion ratio and flip it as we need it. So I could make that 1 foot over 12 inches. And maybe I'll need that for this. Okay, but this is if I needed to convert each one. So I guess what we could have done if we knew this was the question at the start is convert every inch dimension into feet. And so we would divide each number here by 12 in order to find the equivalent decimal feet that we're dealing with. And then it would look like the last problem we just did working in decimals. But let's say you just jumped right in. This was the question, but you didn't see it. And now you have a final answer in inches squared. How in the world do you get it to feet squared without redoing the whole problem? And so that's what I want to show you right now. So notice that each time we did this work, we had inches times inches. Well, there's 12 inches in every foot. So we actually have to change in an area both dimensions. And so this is the other conversion factor you need. We need that for every 1 foot squared, there are 144 inches squared. I'll write that in square in just a minute, per every 1 square foot. Okay, I'm almost there. All right, so for every 144 inches squared in every square foot. Now, how did I get the 144? Well, remember, we have to change both dimensions. So I have to change length and width. So in a total square, that was 12 inches and 12 inches. That'll get me in 1 square foot, right? Because 12 inches, this is 1 foot in length here. And this is 1 foot in length here. I'm just writing the unit, so it's 12 inches. Then that will be 144 square inches, which we already know a 12 by 12 in inches is the same as 1 foot by 1 foot. Right? And so 1 foot by 1 foot is feet squared, which is what we have here. And 12 by 12 is 144. So this is equivalent. So let's use that to help us out. We have 174 inches squared. I'm probably going to write this in a way that you wouldn't imagine, but it's common to do this type of work in physics and chemistry and pre-calculus also. So go ahead and do how you are planning on it. The way I write it on the whiteboard might look way different, and that's okay. I do it this way. This is called dimensional analysis because your units will tell you if you're multiplying or dividing, and you really never make a mistake. Because some of you might be asking, okay, I've got 174 square inches. I have this conversion factor. Am I multiplying or dividing these two numbers? Well, this way can show you. So remember I said this could flip, and I want it to flip. I want to write, whoops,
1 foot squared over 144 inches squared. Okay. And the way I want to write that, or the reason I want to write that, is because now I have inches in the numerator and inches in the denominator. Now, this is no different than if you had like 7 in the numerator and 7 in the denominator. You'd cancel them as a value of 1. And that's what we get to do here also. Inches squared cancels with inches squared, and we're left with feet. That doesn't really look like feet. We're left with feet squared, which is the desired result. Okay. So what that means is this is really over 1, and you're just using your rules of fraction multiplication. Numerator times numerator over denominator times denominator, and then do your division. So as you do a quick scan, that should be 174. It's actually feet squared now because feet squared was not a unit that canceled. But the inch squared did cancel, and that's all over 144. There's no unit down there. We lost it through a value of 1 cancellation. And so now we can see that although I set up what looked like a multiplication, it's actually a division. So that is 174 divided by 144, which I guarantee you a lot of you were like, Mr. Gallus, hurry it up. I know what this answer is. I can see it already. You have to divide. And I am totally with you there. And although a lot of students tend to hate this method at first, once they realize its value and get comfortable with it, they realize what a godsend it is in chemistry and physics classes. So it's always good to just show you a little preview of where your classes can intertwine with each other over the years. So this is what my calculator tells me it is. 174 divided by 144 is 1.208, repeating 3. I think it's wise for us to round. And so maybe, although we're not necessarily going back here, those are all whole numbers. I'd hate to just call this 1. So let's call this 1.21. And this is feet squared. So now we have our final answer should your teacher ever ask you to convert units. 1.21 feet squared is the equivalent of 174 inches squared. And this also is closing our video. And so hopefully when you take a look at this, you can see how throughout the whole process, we treated our units like numbers. And so inches times inches became inches squared. And that's how we used our units through surface area calculation.
So I hope that video was helpful in helping you understand that content. If you are interested in knowing more about this or another topic, do not hesitate to reach out to me. You can always email. If you have YouTube permissions from your parents, you can comment below and tell me what topics you would like to have added into my video list to help you with your continued math learning. And don't forget, if there is science stuff that you need some help with, I can work on providing materials for that also. So I hope it was helpful. Good luck in all that you do. You're all wonderful people.